Hi everyone, welcome to Job Viewer. So today we are going to continue our video tutorial of data structure. So we are going to cover circular linked list today. So we are going to cover some of the topics in this video tutorial. So what is circular linked list? Then types of circular linked list. Then internals of circular linked list. Add element at first position in circular linked list. Add element at last position in circular linked list. Delete element at first position in circular linked list. Delete element at last position in circle linked list, and display circle linked list in forward traversal. And then we'll do coding questions of linked list. Actually we are going to do coding questions parallelly, so we'll firstly understand the approach, how can we do, and then we'll do the coding. So we are going to, this tutorial is related to only for beginners, so we are going to cover only from basic, and then we'll cover to advance. So if you are advanced person, then you can go to last of the video, that means middle of the video, and you can see all the coding related things, coding related approach. So now we are going to continue from basic. So let's get started. So firstly we'll try to understand what is circular linked list. So if you know, circular linked list is a type of linked list. Okay. In previous video we have seen singly linked list and doubly linked list, and this is a third type of linked list. uh, so a circle linked list is a type of linked list where the last node point back to the first node. Okay, so our last node will point back to the first node, creating a circular structure. Unlike a traditional linked list where the last node point to null, in the circular linked list you can traverse the list indefinitely. So we seen singly linked list. So in singly linked list, last node was pointing to null. Okay, but in circular linked list, last node will not point to null, so it will point to address of your first node. Okay, so this is difference between singly linked list and circular linked list. And this is circular structure. Okay, so the last node next pointer point to the first node. No null node. Okay, so all nodes contains value of your next node. Okay, so there is no any null reference. Okay, inside your node traversal. So you can start from any node and traverse the entire list by following the next pointer. Okay, that means you can start from middle also, and you can go from middle to all the nodes. Okay, you can search all the node. So types of circular linked list. Okay, so we can implement circular linked list with the help of singly linked list. Okay, so and we can implement the circle linked list with the help of doubly linked list. Okay, so these are the types of circle linked list: singly circle linked list and doubly circular linked list. So you know the singly linked list and doubly linked list. Okay, in singly linked list it point the address of next node. Okay, and in doubly linked list each node point to address of your next node and previous node. Now we are going to see internals of circular linked list, how circular linked list works. Okay, so if you want to store data, okay, in with the help of your linked list, okay, circular linked list data structure, then how can we do? So firstly it will create one node. Okay, inside that node we have data and we have address. So address point to your address of your next node. So now we are going to create multiple nodes. Okay, in multiple nodes we will store the multiple data. So see, this is the first node. So here data is 10. So we are storing data 10, and this is the address of your next node XX20, and this is the address of your first node, which is XX10. XX10 is the address of your first node, and XX20 is the address of your next node. So this is the second node. So address of second node is XX20. So your first node is pointing to second node. See, first node is pointing to second node, and then this is third node, data is 30 and is pointing to XX40, that means the fourth node. So and this is XX30, and see, second node is pointing to XX30, and now this is fourth node, and fourth node, that is the fourth node is XX40, and third node is pointing to XX40. This is the head of, okay, so head, okay, head is also a type of node. So head, what is the role of head here? So inside head we keep track records of your first node. Okay, so we can track the circular linked list with the help of head. Okay, so it is same as singly linked list. Okay, so head points to your first node of your circular linked list. So this is first node, this is second node, this is third node, this is fourth node, and see, this fourth node is pointing to first node. So it's creating a circle from node 4 to node 1. So this is internals of circular linked list. How, like this circular linked list internally works. Okay, so hope you understood all the points. So now we are going to see add element at first position. So how can we add element at first position in circular linked list? So we have two conditions: if linked list is empty and if linked list is not empty. So firstly we'll see if linked list is empty, then how can we add. So if head equal to null, that means there is no element inside linked list, because head is not pointing to anything, your head is null. So linked list is also null. Okay, so how can we do? So we have to firstly create a node. Okay, this is our node, new node. Okay, so address of new node is xx50, and its content value 50. Okay, and its content null. Okay, so it's not pointing to any address. So now we are going to replace value of head by address of new node. So how can we make connection between both? Okay, this is head, which is null, and this is new node. Okay, so how can we do? So if you'll provide the address of, if you will, that means the tail, that means this is your first node, so we have to provide the address of first node inside head. Okay, so we have to do head equal to xx50, so it will point to, so by default our value head is null, so we are going to replace value of head by address of new node. Address of value is new, address of new node is xx50, so we are going to replace head equal to, so we have deleted null, and now we have replaced it by xx50, which is address of first node, and now head is pointing to your first node. So like this we can do. This is a first step, and after that we have to replace address of new node by address. Okay, so replace address of new node. So now this is a circular linked list, so at the last of your circular linked list it should contain the address of your first node. Okay, so in this case this is the first node as well as second node. Okay, so it should contain the first node. Okay, so what will be the first node? So first node will be also this. Okay, last node will be also same node, so it should contain the address of your address of itself. Okay, in null, instead of null it should contain address of itself, which is xx50 we have to provide. So replace address of new node. So this is address of new node by address. So by address, that means the address of new node. Okay, new node only. So here it will be, so we are going to delete address of new node, and instead of null it should be xx10. Now it's a completed. So now we have added successfully our first node inside circular linked list. So like this we can add first element inside circular linked list. And now we are going to see when, if linked list is not empty, then how can we do? That means the head is pointing to something, and this is the linked list. Okay, which we are going to take as an example. So we have node 1, node 2, node 3, node 4, and this is head is pointing to first node, and at last first node is pointing to second node, second node is pointing to third node is pointing to fourth node. Inside fourth node xx10 is there, so xx10 fourth node is pointing to your first node, this x16. So now we are going to understand how can we add element at first position. So this is our already existed linked list, so it should be our new node should be here, okay, and it should link to your first node, and inside head it should be what should be available, address of first node, okay, and last node it should store, instead of x16 it should have stored the address of your first node, okay. So we are going to follow three steps for this. So first we will create a node, so we'll create one node. So this is a node which address success 10, but default value is 50 we are taking here, okay, and default we are taking here null, it's not pointing to anything. So now how can we do? So replace address of new node by head value. So replace address of new node, so this is address of new node by head value, okay. So head, that means the head is pointing to first node, so we are going to replace this address of new node by first node, okay, and first node is stored inside your head. So null will be deleted and there x10 is available. Now x10 is pointing to your first node, so first step is done. Now we're going to follow second step, which is replace value of head by address of new node. So replace value of head, so this is value of head which is x10. So now what should, instead of head, what should be here, it should be address of new node, okay, so it should be xx50. So now we'll delete the address, sorry, head value which is xx10, and now it should be xx50 which is address of new node, and now it will so it is not pointing to previous node, okay, that means the node first. Now it will point to your new node, okay. So now this is the first node and this will be the second node, okay, this is third, this is fourth, this is fifth, okay. So now head is pointing to your new node which is first node now. So this step is also done. So now we are going to this one, fourth step, which is replace address of last node by address of new node, okay. That means that we have to do here at last also we have to, what we have to do, so it should point to the address of your first node. So now first node is xx50, so in this is of xx10 it should be xx50. So now xx10 will be deleted, and now xx50 will be available. And so now xx50, that means the node 4 is pointing to direct your first node, okay. So we are making here one circle, so xx50 is pointing to, sorry, xx40, that means node 4 is pointing to new node, okay. So here xx50 is inside node 4. So see, this is address of new node, so it's making a circle. So because of this structure we call it circular linked list. It's making one circle from new node to new node to new node to node 4, and node 4 to then new node. So it's making a complete circle. Because of this behavior we call circular linked list. So now we understood how can we add element at first position. So now we are going to do parallel coding, okay, so that it will be easy to understand, okay. So I have already created one class, okay. So I'm going to switch data structure, this window, circular linked list, okay. So I have already did some POC. I'm going to remove everything and we write from scratch. Yeah, so we have one circular linked list class, we are going to create circular linked list. So how can we do, okay. So for that purpose, firstly we have to create one node, okay, node class, okay. So that will contain data and address. So we are going to private class node, okay. Node will be one private class, and so it will contain int data, okay. So we can make it private int and data, and then private string no. So what should be the next type? Next we will store the address of your reference of your next node, okay. So it should be also a node type, because if you want to store the reference of node, so it should be also a node type, otherwise it's not possible. You will get the compile timer. You can't store a reference of your node inside a string. So for that purpose we have to take node only. So now we have data, now we have next. Okay, and now we are going to create constructor, so that if we create the node, so it should assign the value. So generate constructor and select all. So now we have created constructor. So let's arrange properly. Yeah, so we have created constructor. So constructor to create node. Okay, so at the time of creating node, so we will provide the only data. Okay, so that means the we are not providing any next value. So next we are providing, next will be null by default we are making. Okay, and so now we have complete one node class. So we'll arrange. Okay, now we have node class. Okay, so inside circular linked list we have node, and we are going to keep track of head. So private. Okay, what will be the head type? Head type will be also a node. Okay, so private node, node and head. Okay, why you are taking node as a head type? Because okay, head will store the reference of your first node. So node is, first node is also a type of node. Okay, so reference we are storing in, what we are storing inside head, we are storing reference of your first node inside head. So head should be also a node type. Okay, if you want to store a string, so in another string, string A is there, if you want to store inside a string B, so string B should be also a string type. So same here also, here we are storing the address reference of first node. So this head should be also a node type. So now we have declared node head, and now we are going to keep track record of size. So private int size. Now we have, okay, so we have created the required necessary all the parameters, all the variables. Okay, properties, which is head and then size and then node. Okay, so we have everything. So now we can create all the methods, okay, which is required. So first we are going to create one main method, which with the help of main method we'll test this circular linked list. Okay, inside, so inside this circular linked list class we are going to create all the methods. Okay, firstly we are going to create one method which will allow to add your data at first position. So public void add first. Okay, so we have created one method, and it should take int data. Okay, integer. And so we have two condition. Okay, what will be the condition? If linked list is empty. Okay, and again what will be the another condition? If linked list at first position. Okay, so if linked list has, if linked list, circle linked list has one element. Okay, we can make three condition. And if linked list, or you can do cll, circular linked list, cll circular linked list, and cll has more than one element, that means node. Okay, more than one element, that means node. So don't be confused between element and node. So I'm making everything clear here, node. Okay, so now we have three conditions. We have to write code for all the three conditions. Okay, if you're writing at first position, so if cll is empty, so how can you identify if cll is empty? If head is equal to null, nothing is pointing to head, that means the this is empty. Okay, so in this scenario, okay, how can we do? So firstly we have to create one node. So node we can create under top. Okay, new node. Okay, so new node is equal to new node is equal to new node. So we are creating node with value 10. Okay, so now we have created. Okay, and that node will use in every scenario. if CL is empty, so here we are going to write. Okay, so we have created node, and same thing we are going to, if head equal to null, then in this scenario what should we do? So head should point to your new node, so that means that head equal to new node. So it's done. Okay, this is a one line of code for this condition, and it should return, it should not go ahead, because we have added. Now if CLL has one element, not, so we have to do some one line code also, it should be two line code. Okay, because head is pointing to new node, but inside what should we have to do some changes, because the node, inside the node, it should also point the same node, that means it should point the itself. Okay, so we have to inside new node. Okay, so like we have new node dot next. Okay, equal to, we have to provide the address of new node, so it should be new node. So new node dot next will be, sorry, yeah, because this will be the only one first element. Okay, so new node dot next will be also new node. Okay, so this node is pointing to itself, and then head will be new node. So now we are returning, and we are keeping track of size also, so we can make it size plus plus here. Okay, so now it's done. And if CLL has one element, so how can we do? If CLL has one element, then how can we identify if CLL has one element? That means we have head. Okay, so head if head dot next, okay, if head dot next equal to head, okay, that means the head is pointing to your first node. If first node dot next is pointing to head, that means itself. Okay, that means the it has only one element. Okay, if head dot next, that means the first node dot next equal to first node, then only one element. So you can write this logic to check if CLL has only one element. So we have only one. So how can we write the logic if only one element? So firstly we write new node dot next equal to head. Okay, so it will point, now new node dot next will point to the first node. Okay, and what we can do, we can do head dot next. Okay, head dot next, head dot next equal to new node. So if only one element, okay, if CL has only one element, then what we can do, so new node dot next equal to head. Okay, what we created, what we created a new node, so new node dot next we can do head, because head is pointing to your first node, and then we are going to change. Okay, so this logic we are writing head dot next equal to new node, that means the this will be the last element. Okay, so last element, so set address of first element, first element, set address of first element to set address of first, set address of last node to first, to address of first node. Okay, so when we did new node dot next is equal to head, that means that this is the our new node, so this will become the first node. Okay, and already available node which is head. Okay, will become the second node. Okay, that means the last element. So here we are providing the reference of first node. So here dot next we are doing the new node. So now new node will be your first node. So we are setting here head dot next is equal to new node, and at last we'll do head. We'll assign we'll assign value of first node inside head. So what will be the value of new node? First node, what will be the value of first node? So new node is our first node now. So we are going to provide head is equal to new node. Okay, so like this we have done all the three steps. Okay, when circular linked list has only one element, and then we can do size plus plus. Okay, because we are adding, and we can return. Okay, so it should return from here. And we have third condition, if CLL has more than one element. So in this scenario what we can do, so when we adding element at first position, so firstly we will add the head value at inside our new node. Okay, so firstly we'll do new node dot next equal to head. Okay, so this will be applicable for new node. Okay, so we have done. And now what we have to do, we have to find the last element. Okay, and then we can set the, so find element, that means the last node. So we have to find the last node, and then we can, so if we find the last node, so this is our last node. Okay, so we have already added element at first position. So if you find this is the last node, then we can assign the address of new node inside node 4. Okay, so firstly we have to find out the node 4, that means last node, and then we can do node 4 dot next. Okay, equal to head. So same thing we are going to, firstly we'll find and then we'll do the code. So for finding the last node, we are going to write some logic. Okay, so node current node. So now current node is pointing to head. Okay, so we'll do current node equal to current node dot next one by one. Okay, so it should be while. So how can you find last node? So if you'll do current node dot next, okay, equal to null, sorry, equal to head. Okay, so if current node dot next equal to head, that means we are at last position. Okay, so here we are going to, our loop should work till not equal to head. Okay, so we will be at second last. Okay, and then we can do next, then we will get the last node. So this should execute till current node dot next not equal to head. Okay, so now we can do current node dot next, current node equal to current node dot next, and like this we can find the our last node. Okay, node equal to, we have assigned the head value inside the current node, and we are checking the loop. If current node dot next not equal to head, so it should be current node equal to current node dot next. So like this we can find the last node. So this will be our last node. So now we can set address of first node, that means the address, that means the reference. Okay, address of first node, address of first node inside last element. Okay, so now we have last node which is current node. So current node dot next equal to, we are going to first node. So where is first available? So inside here, inside here we have address of first node. And now we can head equal to head will point to new node. So current node dot next. So this is the last node dot next equal to, so head. So now current node dot next equal to head. So last node is pointing to head, but our head is pointing to, I think, previous. It's not pointing to new node. It's pointing to first node. Okay. So now our new node will be our first node. So here instead of head we have to provide new node. Okay. So now current node dot next will be new node. Okay. So last node dot next will be new node, and then we can assign new node inside head. Okay. So our code is completed for adding the first element, and now we can do size plus plus. Yeah. So it's done. So we have written logic to add linked list at first position, link to add node at first position. So it's done. So now we are going to write logic to add at last position. So public void add last. Okay. So we write, and for that purpose we are going to understand, so how can we write logic to add at last position. So add element at last position, we are going to see if linked list is not empty, then how can we write logic. If linked list is not empty, that means head is pointing to any node. Okay. So it's pointing to xx10. So xx10 is pointing to xx20, xx20 is pointing to xx30, xx30 is pointing to xx40. So we have four node, and xx40, okay, which is fourth node, is pointing to first node, which is node 1. Okay. xx10. So this is our circular linked list. Okay, we have fourth node inside circular linked list, and head is pointing to your first node. So now we are going to add at last position. So our linked list should be added here. Okay. And what you are seeing inside fourth node, it should be, that means we are seeing in node for what is available. So in the state of next we have address of first node. So if you will add the fifth node, so in fifth node also it should point the address of first node, okay, which is xx10. And yeah, then I think then everything will be fine in, and head will also point to xx10. So we are going to create one node, and this is the node with address xx10 and value 50, and it's not pointing to anything, no, it's pointing to null only. And then find last node of the element of linked list. So for that purpose we have to find out the last element of the linked list. So this is the last node. Okay, this is will be the last node, and after finding the last node we can do some changes here. What we can do, so here we have to provide the, instead of x10 it should point to the new node. Okay, instead of x10 it should point to new node, which is xx50. And instead of null it should point to first node, that means xx10. So firstly we are going to replace address of last node, address of this is last node, by address of new node, that means xx50. So now xx10 will be xx50. So xx10 is deleted, and now xx50 is there. So xx50 is pointing to, now our fourth node is pointing to new node. Okay, so it's done. And then we'll do second steps, which is replace address of new node by head. So this is the new node address, this is the null we are getting it by default. So we what we'll do, so we'll delete this, and we'll inside this at the time of at the place of null we'll provide the address of first node, which is xx10. Okay, xx10, and xx10 is available inside head. So now we're going to delete null, and it will xx10, and it's done now. So now this new node will point to xx10, that means first node. So making a one circle. Okay, so like this we can add element at last position. Okay, so firstly we'll do the coding and then we'll try to see how can we delete. Okay, so we are going to add, so going to write logic to delete from last position. So we are going to follow, so we'll check if cll, okay, is empty. Okay, if it is empty and you want to add, then how can we add at last position? And if cll is not empty, okay, so we are going to check two condition in this scenario. Okay, at the time of adding last, so if cll is empty, that means there's no any element. Okay, so it should be first also, it should be last also, so it should treat as same. Okay, like at first, so we are going to copy same code. Okay, if cll is empty, from top, and we'll paste here. So this is done. So now we have to follow this if cll is not empty. So new node. Okay, we have to create the new node. So this code will also copy. So in industry of 10 we can provide data here. Okay, so it will not add hard coded data. Okay, so we can copy this node value, node creation code, and we can paste here. Okay, so it's done. If cll is empty, if cll is not empty, then we can write our logic here. Okay, so how can we do if cll is not empty? So firstly we have to, we can do new node dot next. What we can provide new node dot next, we can, new node will be our last node, so we can last node dot next, we can provide the address of first node. So where is the address of first node is available inside here, so we can do. So this is completed. Now we have to change the address of your last node. Okay, and last, it's address of last node, that means the address of your last node should point to your new node. So for that purpose we have to find the last node and then we can change. So find the last node or last element. Okay, so find the last element. Okay, and then we can change the address. Okay, so for that purpose we have written, how can we find the last node? So for that purpose we have written logic. So like this we can find, so copy that logic from top and paste here. So now we have last node. Now our current node is our last node. So this is, so we want to change address of reference next, we want to change next of last node to new node. Okay, so now current node dot next will be your new node. So current node dot next will be new node, and that, and then we can do size plus plus. Okay, because we have added one element at last position. So like this we can do. So we have done. Now if CLS is not empty, so we have, this is the first step. Okay, we have changed the next address. Okay, of new node, and we have done the head, and then we have finded the last node, and we have changed the next of last node, which is new node. Okay, so this is done. So now like this we can add element at last position. So we have done. So now we are going to print. Okay, how can we display? So for that purpose I'm going to write one method which is public void print. Okay, so we are going to print by forward transversal. Okay, so how can we print if linked list is empty, then how can we print? Okay, it should return, that means the linked list is empty. Okay, if linked list is empty, and then if linked list is not empty, if linked list is not empty. Okay, so if linked list is empty, that means head is pointing to null, head equal to null, then it should, what should it should return? Sysout system dot out dot print ln. Okay, that means cll is empty. Okay, empty, empty, and it should return, normally simply it should return. Now done. If linked list is not empty, then how can we do? So firstly we have to find element one by one. We have to take the element and we can print. So we have written logic to find last element, so it will go from first to last only. So here we can, with that of this logic we can find. So this is the current node, this is the first node, and with that of this we'll get the first node, and then we are getting the one by one last till last node. So it will go first, then second, then third, then fourth, like this. So we can simply print here. Okay, so inside we can print, so like this we can print the element. Okay, so end node dot data. Okay, so first time it will print the data which is available inside first node. Okay, because this is pointing to head, current node is pointing to head, and then it will do current node is equal to current node dot next. Okay, so like this, and at last, so we can print the value till second last element, and at last we have to print the value which is inside last element. Okay, so like for that purpose, current node dot last, we have to print last element, last element. So like this we can print last element. So this is done. So now we can check how can we. So now we have done everything. So let's create one quickly class, and we can do cll equal to, we can add and we can display. Cll is equal to new circular linked list. Okay, and we are going to add cll dot add. First we are going to add 10, and then cll dot add last. Okay, sorry, cll dot add, you can add at first position 20, and then cll dot print. Okay, so let's print and check are we able to get correct output or not. So run it. So we have added 10, and then we have added 20, so our output should be 20 and then 10. So 10 add last, here should be data. Okay, int data we have to provide here. Okay, it's a, yeah, so we are getting 20, and then we are getting 10. Okay, so that means that it's right, we are getting correct one. And then we are going to add cll dot add last. Okay, so what should be the output? Now output should be 20, 10 and 30. So let's run again and check. 20, 10 and 30, yeah, that means that we are getting the correct output. So add again at last position, cll dot add last at 40. Okay, and let's check again. Yeah, we are getting 20, 10, 30 and 40. We are able to add correctly at first position, at last position, so it's working perfect. So hope you understood till now. Then we'll going to write code to delete from first, and how can you delete from last. So now let's follow ppt again, and we'll do. Now we are going to delete element. Okay, so firstly we are going to see if linked list has only one element, then how can we delete. So we are going to delete from first position. Okay, so this is our data, that means the linked list has only one element, then how can we delete. So this is element which is available inside linked list. Okay, so this is pointing to head. Okay, so now we can say linked list has, equal linked list has only one element. Okay, head is pointing to xx50, and xx50 is pointing to itself. Okay, so how can we delete? So replace value of head by null. Okay, if you will do head equal to null here, so automatically it will be deleted. That means the head will not point to any node. So this is so simple to delete if there is only one element. Okay, so let's delete. So now xx50 will be deleted, and instead of xx50 null will be available. And so now head is not pointing to anything, so now node is deleted, which is inside CLL, circular linked list. So like this we can delete the element. And now we will delete element at first position if linked list has multiple elements. Okay, so linked list is not empty, so how can we delete? So if linked list has multiple elements, so how can we? So this is the head. That means the head is pointing to x extent. That means that there are multiple elements. Okay, inside there is element inside CLL. Okay, so head is pointing to x extent, and x extent is pointing to xx20, xx20 is pointing to xx30, xx30 is pointing to xx40, xx40 is pointing to xx10. Okay, so this is a one complete CLL, circular linked list. So now we are going to delete element at first position. So this is our first position. So it should be deleted, and instead of this head should point xx20. Now head is pointing to x10, so head should point xx20, and this should be deleted. And instead of this, in node 4 we are getting xx10, which is address of your first node. So instead of xx10, it should be xx20. Okay, because this first node will not be available. Okay, after deletion of this node. So we are going to do two steps. So firstly we are going to replace value of head value of head, this is value of head, by next address of head, by next address of head. That means value of head by next address of head, which is xx20. Head dot next will be xx20, which is address of your next two node 2. So if you replace this xx10 with xx20, then this node will be ignored. So we are going to do. So now x16 is deleted, and now we have set xx20, and then this is not pointing to node 1. Now this will point to node 2. Okay, so like this first node will be deleted. Now first node is deleted. Okay, so it should not be here. Okay, so it should be, it is deleted now. Okay, so it is deleted, nothing is there, it should not be available here. Okay, so we have deleted. let's let's Okay, so now we have deleted. Now what we can do, so we are going to see second step. Okay, so what is second step? Replace address of last node by head. Okay, so we have deleted the xx10. So now xx10, instead of xx10, what should be available? It should available the first node. So now what is first node? So now this will be the first node, xx20 will be our first node. So instead of xx10, it should be xx20, xx20. So now let's delete xx10. So this is our last node, and then we are deleting xx10. Now xx20 is the head value, that means the first node, and then it will point to the your first node. Now node 4 will point to the first node. So there is no any node 1, we have deleted everything from. Okay, so head is also pointing to node 2, and last one is also pointing to node 2. So this is one complete CLL, circular linked list. Okay, we have deleted deleted from first position. So it's done. So now how can we delete at last position? So we are going to delete from last position. So how can we do? So if linked list has multiple element, okay, if linked list has multiple element, then how can we delete from last position? So head is pointing to x16. That means the linked list has multiple elements. Linked list has elements. Okay, some elements are available inside linked list. So xx10 is pointing to xx20, 20 is pointing to xx30, xx30 is pointing to xx40, xx40 is pointing to xx10. So we have 4 node, and head is pointing to first node, and node 4 is pointing to first node. Okay, so it's making a circle. This is a CLL. Now we are going to delete at last position, so this should not be available. Node 4 should not be available. So how can we do? Instead of xx40, sorry, instead of xx40, okay, which is available in node 3, if you'll make it xx10, okay, if node 3 will point to x node 1, then node 4 will be ignored. Okay, so it will not be available. So how can we do? So we can find the second last node, which is node 3, okay, and then we can do node 3 dot second last node dot next equal to first. First, that means the head value you can assign. Second node dot next, second last node dot next equal to head. If you do, then this fourth node will be ignored from our CLL. So like this, we can delete element from last position at last position. So let's follow the steps. So traverse to the second last element. That means that we have to come to the second last element. So this is the node 3 second last element. So we can, so this is our second last element, and then we have to set replace address of second last element by head. So like replace address of second last element, which is this one. This is address xx40 by head. So head is xx10. Head is pointing to first element. So now xx40 should be xx10. So now let's delete xx40, deleted. Xx10 is here, and now this is not pointing. So now everything is deleted because node 3 is not pointing to node 4. So there is no there is no any difference between node 3 and node 4. So it's making a complete circle from node 3 to node 1. Inside node 3 there is xx30, xx10, which is address of your node first. Now it's done. So like this we can delete element at last position. Okay, so now we'll do the coding for both the thing, which is, let's continue the coding. Okay, so firstly we are going to write one simple code to get size. Okay, so public get int get size. Okay, and and it will return size. Okay, so we will also try to print the size. Okay, how, what is the print size? Okay, system, because we are also keeping take record of size. Okay, print ln and size, size size. How can we get size? So cll dot get size. So let's run. So you are getting size 4. So we are getting the correct size. Okay, so now we are going to write logic to delete element from at first position. So public void delete first. Okay, and so this is the method. So we have two condition, three condition. We are going to check if linked list is empty. Okay, if linked list has only one element. Okay, and if linked list has more than one element. Okay, linked list has more than one element, you can make it cll. Okay, cll. Okay, and so cll is empty. So how can we do? If head if head is pointing to null, that means cll is empty. If head equal to null, that means we will print one message, simple message, sysout dot system dot out dot print ln. That means cll is empty. Okay, so we can't delete it. So and return ret return. Okay, So there is nothing inside CLL. So print one normal message CLL is empty and then return from here. Okay, and then if CLL has only one element, so how can we do? How can we check CLL has only one element? So we will copy from top. We have already written. How can we check? Yeah, head dot next equal to head. Okay, so if head is the same node is pointing to itself, so that means the only one element. So we have copied the code from top, and now we will write. How can we delete if only one element? So normally we'll do head equal to null. Okay, so now head is not pointing to anything. You can do, and we can do size minus minus. So we have deleted, so we can do size minus minus, and we can simply return from here. Okay, so we have written the logic for this also, and now we have third condition, which is if serial has more than one element. So how can we do? Okay, so for that purpose we have to go the last element. Okay, so we have to go till last element. So we have to firstly last find last element. Okay, find last, we have to find the second last element, because we are going to change the next address of second last element to the your first. Okay, so find second last element. Okay, so how can we? So we have written the code to find the last element, so we'll modify some modified code here. Same code will modify the to find the second last element. So see, so previously we were keeping track record of current node and only current node. So we are going to make, we'll keep track of current node and second node. Okay, so current node will become last node. Okay, so this will be the last node, and then this will be the second last node. Okay, so SEC, okay, simply is sec last node. Okay, so last node we can get. Actually we are deleting. So this method is to delete first node. Okay, so we no need to write this all code. Okay, this code will applicable to write to delete the last node. Okay, so we are deleting the first node, so let's remove from here and write the logic to remove the first node. So we are removing the first node. Okay, so first node, that means the, so head will point the first, head will point the address of first node. So we can do, if inside head, if you provide the address like head equal to head dot next, then it will not point the first node, it will point the second node. Okay, so like this we have to do. So that will be the second step, and first step what we have to do. So let's change the address of your last node to second last element, sorry, second element, because we are going to delete the first element. You are going to delete the first element, so now last node will point the, so now your last node will point the second element. Okay, because first node will be deleted, and now second will be your first node, so last node will point the second node. So firstly find the last node, and then we'll change the address of that node. So find last node, so we'll take the same code to find the last node. Okay, so we have finded the last node, and then we'll do some modification. What we'll do, so at last node we have last node dot next. What we'll do, head dot next, last node dot next equal to head dot next. That means we are changing the last node, next of last node equal to head dot next. That means head is pointing to first node, so if we'll do first node dot next, that means the we'll get the value of second node. So like this we can change the address of your last node, and then inside head what we have to do, so head should point to your second node, so you can do head dot next. So now head will point to second node. So this is the two lines of code, but before that we have to find the last node. Okay, so we did the this head dot next equal to head. Okay, so this one we did in second steps because our head value will be correct. Okay, so firstly we did this because we'll get the correct head value, and then we did the head equal to head dot next. Okay, so it's done now. So let's do size minus minus because we are deleting it, size minus minus. Okay, and then it's done now. We have written the code to delete the element from first position. Okay, so let's write the code to delete from last position. So public delete last, public delete last, and make it wide. So we are going to delete from last position, so we are going to write same three logic, three condition. Okay, if linked list CLL is empty. Okay, if CLL has only one element. Okay, only one element, and if CLL has more than one element. Okay, so three conditions. So if CLL is empty, then how can we delete? So same we'll copy from top. If CLL is empty, so we'll copy from top. This is done. And then if CLL has only one element, that means the so so we can also copy the code from top. For this code will be same because only one element is available inside your CLL. Okay, and now we are going to write logic. If CLL has more than one element, so how can we delete from last? Okay, so for that purpose we are going to write our logic. So how can we do? So firstly we are going to delete from last. Okay, so last node contain the address of your first node. Okay, so if you delete the last node, so our address of first node should be available inside your second last node. So firstly for that purpose we have to sorry, so for that purpose we have to find the second last node. Okay, and then we can do second last node dot next equal to head, because head will point, head is pointing to address of your first node. So firstly find the then find the second last node. So we have logic to find last node, so we'll modify this code to find the second last node. So write here this logic, and now current node we will make the second last node. Okay, now head will point to the second last node, and now node last node. Okay, last node equal to head dot next. So we can make it current node. Okay, so current node. So this is our second last node, and second node will be the last node. So this will be the last node. So don't be confused. So second last second last node will contain head value, and the current node, that means the last node, will contain the head dot next. Okay, next to that. Okay, and then we are checking if current node dot next not equal to head. Okay, so previously, let's remove this one. Previously we were storing current node equal to current node dot next. Okay, so now we'll store the second last value also. So second value, what will be second last value? Second last value is equal to second last value dot next. Okay, so we are keeping track of both the. So now we have second last or last. Okay, both. So like this we can get the second last node. Okay, so here we can set address of last element to head. Okay, so set address of second last element to head. Okay, so we are going to set. So now we have second last node. So second last node dot next equal to head. So address of your first node. So now we have did, and now we can delete size minus minus. We can do. We have deleted. So like this we can write logic to delete the element at which is at last position. Delete last. So it's done. So let's check, are we able to delete correctly or not. So previously we were getting 10, 20, 10, 30, and 40. So let's delete. So cll dot delete first. So it should get 10, 30, and 40. 10, 30, and 40, because we are deleting 20. Delete first. Delete first. Delete first. Okay, so we should delete 20, and output should be 10, 30, 40. So let's run and check. 10, 30, and 40. So we are getting. Let's print cll dot print after deleting. Okay, and let's remove this, and again let's run again. Actually it's not printing. Actually we did some copy paste. Okay, so it's printing the. Actually it did the copy paste, so it's printing the deleted element. So let's comment and then check. Okay, our code is correct. So let's delete this out, and let's print again. Okay, so we are getting 10, 30, 40. So let's comment and then check. Let's comment this cll dot delete first and then check. See, we are getting 20, 10, 30, 40. So 20, 10, 30, 40. So if you do delete first, our output should be 10, 30, 40. Okay, so let's run again. 10, 30, 40. We'll see. So we are getting 10, 30, 40. That means we are getting the correct outputs. And then again, let's delete last. Okay, delete last and then check again. So now output should be 10 and 30, because 40 should be deleted. 10, 30 should be output. Let's run. Yeah, we are getting the 10, 30. That means we are getting the correct output. So we are able to. So let's print the size. Okay, after deleting. Okay, so it should print 2. Okay, serial dot get size. Let's print. Yeah, we are getting size 2. So let's add something. cll dot add first. Okay, and add 40 at first position. Okay, so now output should be about 10, 30, 40. So let's run and check. 40, 10, and 30 should be output. 40, 10, and 30. We are getting 40, 10, and 30, and we're getting size also. So we are getting the correct output. We are able to add at first, add at last, add, delete at from first, and delete from last. So like this, we can perform all the methods, okay, with the help of circular linked list. I hope you understood all the points from initial to last. If there is any doubt, so please let me know in comment section. Anyone, if anyone is interested, can participate, okay, in comment section, and so we can learn together. Hope you understood all the point which I covered in this entire video. So if you are loving my if you are loving my efforts, please like, share, and subscribe. Bye everyone.